So I'll be presenting for Seezo today. My name is Manthan. Sandesh is not here. Okay, so the plan for today is I'll give you the demo of Seezo, how it works, and also a glimpse of our evals and meta prompting pipeline that we have built internally, so that we let you know how do we secure your design as well as how it actually works under the hood. Like what are we doing that makes it secure. So a bit about me. I've previously worked as a senior engineer at Razorpay and BharatX. I was GSOC mentor and committer at Apache, and currently I'm working as a lead and the founding engineer of Seezo. By the way, we are hiring. So if any of you are looking for roles like security researcher, applied AI engineer, or software engineers, please come us at the booth, talk to us. We're actively hiring right now. Okay, to begin, so Seezo operates at the design stage. If you're aware about the SDLC, we start with design, then write code, then deploy, and then maintain the code, maintain the app or the software. So we're right now operating at the design stage. What I mean by that is when at a design stage, there are Jira tickets, ServiceNow tickets, documents, PDFs, Google Documents, any form of input where we talk about architecture diagrams, designs, how the software is going to be built. All this information we ingest. After doing that, Seezo gives you a security summary, open questions, requirements, and the compliance mapping for this data. A lot of the issues that you see today on the production were actual flaws that happened in the design stage itself. For example, you decided to log sensitive data. Now, at a design stage, no one took care of it. You end up logging sensitive data. Eventually, the sensitive data not only has to be redacted, which was logged previously, you also stop it and you check where all did you log. All these issues can be stopped at design stage, and that's what Caesar aims to do. So your developers get early feedback, and you don't have to wait till the code gets deployed, and then you have to fix all your past mistakes. We generate a report in around 5 to 10 minutes. Our expert can do validation and send the feedback back to developers. How Caesar does it is like there are multiple steps. I'll like I've written some main steps right over here. For example, we use multi-model RAG. We do some meta prompting using DSPY. We have LLM evals that ensures the quality of the output is nice. We have decision trees for reduce hallucinations. When you go to agentic flows, ensuring that hallucination doesn't happen and the consistency of the output is met is harder. For that, we use decision trees. I'll show you a demo on how that works. We customize as per your company context, so you don't have to worry about if anything is particular to your company, specific to your company, it's just taken care of. And we integrate with our existing workflows. What I mean by that is, let's say you already use Jira, use ServiceNow, all the automations are already in place. You don't have to change any of your workflows, current workflows, but only just integrate them with Seezo. I'll show like a small demo and then I'll go into other details of things. So these are some of the integration that we offer. For example, Jira, Confluence, Slack, ServiceNow, Lucid, etc. When you come to Seezo, you can start an assessment. We call the entity here as assessment. You can start a new assessment where you can either use the integration that you already done or upload a file or a diagram. This is an example tech spec that I have, a design document that a developer might write when they're developing something like an MVP for LLM gateway. They'll capture details on how it is being built, how the secrets will be stored or will be used, and they'll talk about architecture diagram. We ingest this document directly into Seezo via, let's say, a document scan, a Google document scan, and in the return, we'll give like requirements, open questions, security controls, and assets. The security requirements are interesting. This will help you secure your design. For example, if the design doesn't talk about how do you plan to secure or handle your secret storage, that's probably a design level flaw itself. You probably end up either putting in the insecurely storing in the code or not properly using the env, or maybe just not using the standard practice that is to be followed in the org itself. For example, a secrets manager is to be used. These issues can be identified early and your organization policies and security practices can be enforced. Next, I'll show you how this works under the hood. To do that, we'll just take a very simple example. I've uh, reduced the number of rules as well as reduce the number of complications so that we can take a look at how this will work. Let's take a very simple example. There's a user who opens the browser, enters his PAN number, goes to the backend, and goes to the database. This diagram, if scanned through Seezo, will give you requirements like: are you protecting the PAN number in logs and error messages? Are you encrypting the PAN numbers at rest in databases? How this works is Seezo internally runs a workflow. We have a workflow kind of approach, a decision tree approach, and each line item that you see is a rule. Is sensitive data used in the application is a rule that we run. And when you get an output as yes, we go and ask more questions about this particular information. We have around 1,000 rules like this. So we essentially have 1,000 plus prompts, 10,000 plus synthetic datasets, which are tested across these prompts to ensure the quality is met. This is sample workflow, a smaller subset of it. Since the answer to this question was yes, we went ahead and asked another question like, hey, is there an input field for the UI or there's a browser involved? That is yes. So again, go and ask more questions. So we build a complex decision tree trying to understand your document, capturing information that will help us evaluate the design security of your document. In the end, giving you feedback. The quality is important. In security, at least consistency and quality both are important. For quality, we have an internal evals dashboard build. For example, the document we're looking at LLM gateway. A human would go and write a dataset for it. This dataset is a human written or verified dataset where an expert or domain expert writes it, and we run the document through the Seezo app. When we get the output, we evaluate it against results. Like for example, this particular document has a 66% score. If we go to the assets section, we say, okay, there are 18 correct matches, 6 were extra, 6 items were missed. Eventually, we are building up a big set of data sets. Right now, there are around rather there are 20, 30, 40 or more, but we're trying, other than the synthetic data sets, these data sets we're even eventually trying to increase so that we can ensure the quality of the output is not degraded as we write more prompts, as we change prompts, as we change anything in our workflow. This is a sample report for you. Similarly, we also evaluate consistency. My bad. So because at least in security, probably also healthcare and also legal systems, it's important to output to be consistent. You can't say something at the first time someone asks you and then change your answer right after that. It's probably okay while generating code if the code does the same thing. But in terms of security and some of the other critical applications, consistency is more important than it is for the other applications. We also measure how consistent we are. The aim is to be 100% consistent. Right now, most of our prompts tend to be around 95 to 98% consistent overall. So that's how we ensure that whatever we say, we can repeatedly say it. We are explainable as if we can say it. I'll give a short demo of how do you even get to 1,000 prompts. You probably have never heard it. It's hard to write 1,000 prompts by anyone or anything. So we use some form of meta prompting approach, which is validated by a human. So we start with something called as a mind map, where we have a rule that needs to be written. Let's say, for example, in this case, let's take something like where to determine if sensitive data is used in the application. This rule then gets converted into scenarios, which you like to test upon. Imagine different models doing it. So one model is creating a rule, one model is creating a prompt, one model is creating scenarios. The scenarios are like, how will you test this prompt in a production system? Probably a document can appear where a application features user profile section where users can update their contact information and government ID numbers. If a document has this thing, it's essential that we capture, and this particular rule says yes, that we have found something. A human in the these are auto generated, but human when reviewing it can add more scenarios that they like the test the meta prompt on or the generated prompt on. When I say meta prompt, it basically prompts writing more prompts. So there's no human writing the prompt. Once we do it, let's say a sample prompts get generated. This is again using DSPY, some of the frameworks that we're using, and some of the prompt techniques, which is fairly elaborate. Then the scenario that we're discussing, which is this scenario, we also generate a document. This is a sample document which we generated, which has a real life scenario architecture like a normal diagram, normal uh, text spec will have. And somewhere in the document, the LLM adds this line that's saying, hey, in the user profile section, users are able to update a government ID numbers. As long as we can improve our scenarios, make them more complex, we can generate more complex documents, ensuring that the prompt that we have generated also works decently. That's how we scale to 1,000 prompts. We have like 10,000 plus synthetic documents, all reviewed by humans. The prompts are reviewed by the humans, and in data sets, we try to measure the quality using sampling at how the generated data sets are. In the end, all this synthetic data sets goes back to eval pipeline that we discussed and is stored and ran across every change that we do, ensuring the quality is met. That's Seezo for you. So we also in these diagrams, and in the end, we are able to give you results like security requirements, open questions, security controls, assets, and all of this is eval to the eval platform. Coming back. So what's next for us? So we are trying to build SOTA LLM evals. What we try to do is not stop here, but again expand evals to add, like I mentioned, we are limited number of data sets, increase them to further to in hundreds of thousands, which are hundreds of thousands for in terms of synthetic data sets. And for normal data sets, to let's say human written or real world data sets, which are like open source documents, etc., to near 1,000. Fine-tune LLMs for security for specific use cases like finding deduplication or something specific like classification. Where to create security focused LLM benchmarks, like how are we doing on code reviews, how are we doing on design reviews. we want to implement agentic workflow. So we talked about a requirement where we say, let's say, encrypt customer data that is stored in database, but agents can also go and verify those data if it's already encrypted or not. We're trying to add that. In the last, we're trying to move to the next stage of SDLC. That is not to stop at a design stage, but go to code, go to deployment, go to maintenance, and ensure entire end-to-end AppSec is secured. For that, again, we are hiring. So if you are looking out, just consider applying for us. Yeah, thank you. My name is Manthan. It's nice meeting you. Bye-bye.